comparing radian measure and degree measure. So remember with degrees, we've got 0. Remember we go anti-clockwise for positive angles, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. That's for our positive angles, okay? And if we're ever in quadrant 1, remember our little butterfly, this is theta. This will be, we know that we've got theta in all these places, but this actual angle up to here is theta. This angle here, remember, is 180 minus theta in quadrant 2. In quadrant 3, we have 180 plus theta. And in quadrant 4, remember, we have 360 minus theta. Okay, so that's how our angles are represented in degree measure. We have quadrant 1, 0, quadrant 2, 180 minus theta, quadrant 3 is 180 plus theta, and quadrant 4 is 360 minus theta. Might be a good idea just to draw these bits in another colour. Okay. Now, we're going to do the same thing with radian measure. So again, we've got 0. Instead of writing 90 degrees, it's pi on 2. Instead of 180 degrees, it's pi. Instead of 270, well, all the way around is 2 pi. And halfway between pi and 2 pi is 1.5 pi or 3 pi on 2. And the way that we represent the angles in the quadrants, so if we had, remember we're always interested in the angles touching the x-axis. In quadrant 1, we call this pi. But in quadrant 2, this is pi minus theta. Okay, so instead of 180 minus theta in quadrant 2, it's pi minus theta. Okay, so quadrant 1's the same because it's just theta. So quadrant 3, remember, is 180 plus theta. In this case, it will be pi plus whatever theta is here. So we've got pi plus theta. And in quadrant 4 over here, we've got 2 pi's all the way around, but we're short theta, so it's 2 pi minus theta. Okay, so they're my quadrant 1, 2, 3, 4 angles in radian measure this time. So we go theta, pi minus theta, pi plus theta, 2 pi minus theta. Now, looking at the angles as negative measures. So remember, let's do it in degrees first. So remember we started with 0, however we travel clockwise. We had negative 90 degrees, negative 180, negative 270, and negative 360 degrees. Okay? But if we're using radian measure, we would go 0. Now negative 90 would be negative pi on 2. Negative 180 would be negative pi. This would be negative 3 pi on 2, which is negative 270, and all the way around would be negative 2 pi. Now, so that's 0, this is 0, and then when you make it back all the way around, it's negative 2 pi, not positive, okay? So, again, with our little related acute angles, okay, we would have, remember, we don't start with quadrant 1 for negative angles. We must travel in a clockwise direction. So this is negative theta. Oh, sorry. Yeah, negative theta. This, remember, is negative 180 plus theta. Okay, because always quadrant 3 is plus. Because you're going negative 180, you're coming back in the positive direction for plus theta. This is negative 180 minus theta because you keep travelling in the negative direction. So negative 180 minus theta because I keep travelling in the negative direction all the way. And the last one is negative 360 and coming back. So negative 360 is all the way around plus theta. And remembering what we did the other time, what is the difference between the positive and the negative angles? So to go from positive angles up here to negative angles, the difference is we are subtracting 360 from the positive angles to get to the negative angles. So if you compare this and this, the difference is 180 minus 360 is negative 180. We've still got the minus theta. In quadrant 3, if you take away 360 from the 180, So 180 minus 360 is negative 180. And this last one, if you subtract 360 from that, you lose it, and you're just left with the negative theta. Now, the negative angles here in terms of radians. So we come back and we've got negative theta. And here we would normally say negative 180 plus theta, but this time it would be negative pi plus theta. Okay? The next one is negative pi and still another negative theta. We keep going in the negative direction. So it's negative pi minus theta. And remember, in degrees, it was negative 180 minus theta. And here in quadrant 1, we would go negative 2 pi, but come back for the plus theta. So instead of negative 360 plus theta, it's negative 2 pi plus theta. So they are the negative angles in terms of radians. Just some other questions you could be asked. You could be asked to find exact values. So remembering we were doing these before, but we were in degrees. So now we're in radians. So the sine of pi on 3 really is the same as asking sine of 180 on 3, that's sine 60. It's really asking the same as sine 60, which is root 3 on 2. Okay? So, but this one, sine of negative pi on 6, so remember that's going in the negative direction. Now remember, negative pi on 6, now pi is 180, that's the same as sine of negative 30. So you're just going 30 degrees in this direction. So I can draw it like that, or I can put it 30 degrees. So remember that the sine of negative pi on 6, or sine of negative 30, remember we have to give it as a related angle in quadrant 4. It's the same as sine pi on 6, but is it going to be positive or negative? Now we've got all stations to central. Sine is negative in quadrant 4. Remember, the negative is just telling me to move in the negative direction 30 degrees. So the sine of something with a related acute angle of 30 degrees in quadrant 4 would be the negative, So it's negative sine pi on 6. So that's the same as negative sine of 30, and I could have written 30 there, which is negative 1/2. Okay? Others. Now the cos of 11 pi on 3. Now that's obviously more than one time around the circle, because remember that 2 pi is 360 degrees. So this will be the same as cos of 11 pi on 3 minus 2 pi. Okay? Now 11 over 3 minus 2. Now 11 over 3 is 3 2/3 minus 2. That's 1 2/3. So you can just go 11 over 3 minus 2 in your calculator. So it's the same as the cos of 1 2/3 pi, which is 5 pi on 3. Okay? So you have to bring it back within, so before, if it was bigger than 360, you need to subtract 360 until it's between 0 and 360. So we don't subtract 360, we'll have to subtract 2 pi, because that is 360 degrees, until this fraction here, this angle radian measure, is between 0 and 2 pi, and it is, because it's 1 2/3 pi. Now this is cos, and 5 pi on 3 is, well, you can think of it as 5 lots of 60, because pi on 3 is 60, but it's in quadrant 4, and it's really 2 pi minus pi on 3, so there's pi on 3 left here. Okay? So, cos of 5 pi on 3, like I said, you can think of it as 5 times 60, which is the same, really. You can think of it as cos 300 if you want. Now, cos 300 has, you can put pi on 3 there, or you can put 60 degrees there in quadrant 4. Now that is just the same as cos of 60 degrees or cos of pi on 3. Now cos of 60 is 1/2. Okay? Okay, so you can, if you want, convert it at some stage to degree measure if you want, all right, while you're new. All right, but here I could have put, for example, pi on 3 or 60. Same thing. They're both the same. Okay, the next one, same sort of thing, tan of 17 pi on 6. See, 2 pi is 12 pi on 6, so this is clearly bigger than 2 pi. So you need to subtract 2 pi from that angle. And then we have tan of now 17 on 6 minus 2. You can just do that on your calculator if you want. Well, that's tan of 5 pi on 6. So where is 5/6 pi, that's less than 1 pi. See, this is 0 and this is pi. So 5/6 pi is somewhere there with a related angle of pi on 6 in here. So it's less than pi. 5/6 of pi is 1/6 short of pi. So we've got all stations to central, and tan is negative in quadrant 2, and that little angle in there, the related angle, is pi and 6. So we're looking really for negative tan, of pi and 6. Now, tan of pi and 6, that's tan of 30, so that's negative 1 over root 3. Now, if you want, you can just convert this to degrees to start off with, and just do what you normally would have done in degrees. Okay, so you can write this in degrees as 5 times, now pi on 6 is 30, so it's 5 lots of 30. This is the same as doing tan of 150. Okay, so you can do it like that if you want, by drawing the 150 there. We've got 30 here, and it'll be negative tan 30, for example, which is negative 1 on root 3. Okay? Okay, just a few more. Cot of pi on 3. So remember, this is the same as doing 1 over tan of pi on 3. Now, tan of pi on 3 is, be careful, it's tan of, pi is 180. So 180 over 3 is tan 60. So it's really 1 divided by tan 60. Okay, because pi on 3 is 60 degrees. So you should put your degrees there. So that's 1 over root 3. Okay, now sec, this is 7 pi on 6. So that's really, remember, sec is the reciprocal of cos. So it's 1 over cos of 7 pi on 6. So we really want to work out what cos of 7 pi on 6 is. Now, where is 7 pi on 6? That's 1 and 1/6 pi, because 7 over 6 is a mixed numeral, and it's bigger than 1. And it's pi on 6 bigger than 1, or it's 1/6 bigger than 1, because that's 1 and 1/6. So there's your pi, 7 pi on 6. Now, cos is negative in quadrant 3, all stations to central. So cos of 7 pi on 6 is the same as negative cos pi on 6. So this will be 1 divided by a negative, so my answer is going to be negative. So it's negative 1 on. Now this is cos of 180 on 6 is 30. So it's cos 30. So it's negative 1 over root 3 over 2. Now we don't write it like that. You don't put 1 over a fraction. So it'll just be the reciprocal of root 3 on 2. So it's still going to be negative. It's going to be negative 2 on root 3. Okay? Now if you want, you could have kept this as sec all the way. So I could have gone sec 7 pi on 6 is the same as negative sec pi on 6, and just done it like that, because sec will be whatever cos is in this quadrant, it's negative, and the related acute angle is pi on 6. Okay, so you could have just done it like that, and negative sec pi on 6 is negative 2 on root 3. You could have done that. Okay, maybe we'll try the next one like that. So cot of 5 pi on 4. Now 5 pi on 4, that's bigger than 1. It's 1 1/4. So you've got 0, pi on 2, this is pi. So it's in quadrant 3. So you've got pi and another pi on 4. Okay. So cot is the reciprocal of tan. So cot of 5 pi on 4. So remembering, so I'm just not sure if I was very clear there, that 5 pi on 4 is the same as 1 1/4 pi. So it's 1 pi and another quarter pi. So that's 1 pi and another quarter pi, which is pi on 4. Now that's really 45 degrees, okay? So that's just the same as cot of pi on 4, because all stations to central, I either put a positive or negative here, but tan is positive in quadrant 3. So it's positive, okay? So cot of pi and 4. Now we know that the tan, so that's 1 over tan pi and 4. Now we know that tan of pi and 4 is tan of 45, which is 1. So it's 1 on 1, which is 1. And this one is a negative angle. So negative 2 pi on 3. So we're traveling in the negative direction, less than pi. So we've got 0, negative pi on 2. This is negative pi. 2/3 is less than 1, so it's here. So if this is 2 pi on 3 in the negative direction, then this is pi on 3 here. Because if you've got 2/3 plus 1/3 adds up to 1 whole. So we're looking at cosec. Now, the cosec is the reciprocal of sine. So because sine is negative in quadrant 3, so is cosec. So the cosec of negative 2 pi on 3, remember the negative just tells me to travel this way, is the same as the cosec of the related acute angle. Now it's cosec pi on 3, but is cosec positive or negative in quadrant 3? And it's negative because sine is also negative. So it's negative cosec pi on 3. So this is the reciprocal, so it's negative 1 over sine of pi on 3. Negative 1 over, now sine of pi on 3, that's sine of 60. And sine of 60 is root 3 on 2. And we don't want to write it like that. So it's negative, it's the reciprocal of root 3 on 2, which is 2 on root 3. We actually got the same answer as the other one. Okay.